Hi class, it's Professor Rourke. I've had a few messages from students regarding some questions on 2.4 and sort of being a little confused. We did a lot of proofs and finding epsilon and delta, but these are more practical, and I think once I show you a couple, hopefully it'll make a little bit more sense. Okay, so let's take a look at number 5. That was one question that a lot of your classmates had a question on, and I'm going to do one more separate video on another question. So number 5 says a graphing calculator is recommended, and then it says for the limit as x approaches 0 of e to the 2x minus 1 all over x equals 2. Illustrate this definition by finding the largest possible values of delta that correspond to epsilon equals 0.4 and epsilon equals 0.2. Round your answers to 3 decimal places. Okay, so this problem actually has quite a few steps involved. First of all, we want to make sure that we remember, and you can look at your notes for the graph. You can also sort of look at some of the previous examples. When we're based off of a graph, it can sometimes help a little bit to keep us straight. So epsilon, just as a reminder, is the y values. Okay, so this is pretty much saying, now your numbers could be slightly different. For 0.4, what this is saying, and I'm going to use my graphing calculator, but just to kind of give you a basic idea before we do that. Let's say here's 2, okay, and we know that the limit, they tell us that the limit is 2 as x approaches 0. So I don't really know right now without graphing it what this particular graph looks like, right? Let's just pretend, I don't know, it does something like this. Okay, so what this is saying is that for epsilon is 0.4, that again is the y values. So we want to check 0.4 in the positive direction and 0.4 in the negative direction. So without really doing much actual computations, we should hopefully kind of think like, okay, if I want my y values to be within a distance of 0.4 of the limit of 2, then the upper value I'm going to check is 2.4, and the lower value would be 2 minus 0.4, which would be 1.6. Okay, so what we're going to do is we're going to find the x values that correspond first. Well, you do in either order really, but I'm going to do first, I'm going to find the x value for 2.4, and then I'm going to find the x value for 1.6. Those will give me possible deltas. Okay, delta, delta, and we're going to pick the smallest one, and that is going to be the largest possible value of delta that corresponds to 0.4. Then we're going to do the same thing again, but for epsilon is 0.2. So instead of 2.4 and 1.6, we'll check 2.2 and 1.8. Okay, so I hope that sort of makes sense. So let's go and take our graphing calculators out. And I went ahead and already entered in to y equals e to the 2x minus 1 all divided by x. And to start out, there's a couple ways to do it, but I personally think the easiest way to do this is to set this equal to 2.4, and then we'll find the intersection point. That'll give us the x value. In the examples that we did in class, they were more simple functions. They were just like the square root of x, right? So for instance, for this, if it was just the square root of x, we would set the square root of x to 2.4 and solve for x that way. This is more complex because we would have to set 2.4 equal to e to the 2 to the x minus 1 all over x. And the easiest way, because again, we're just rounding to decimal places, I think would be just to use our graphing calculator to have them give us the x values that we're looking for. Okay, so this is kind of a new step. Then again, if maybe you weren't sure about, there's a few different ways, again, that you could get out this x value, but this is what I think would maybe be the easiest. And you can let me know if you think there's a different and easier way to do it. That's, you can, just as long as you can explain, is all good. Okay, so what we're going to do is we're going to use our calculator. We're going to hit second trace. Now we've used that value, that first one value, a lot when we were trying to estimate limits by getting closer and closer to the value. So we would put in, remember we put in like 0.01 and 0.0001 and 0.00001, all that stuff. Okay, we use value, but we're not going to be using value today. What we're going to be looking for is the intersect, because again, I went ahead and put in the y equals 2.4 as one of the lines. Okay, so it says first curve, and I don't really, okay, there we go. I was like, I don't really see the cursor, but there he is. Okay, push enter. Second curve, it's just talking about the line y equals 2.4. Yes, no thanks. So it tells me this intersection point here is 0.177. All right, so what I'm going to do is I'm going to try to keep this organized, because again, this problem is quite a few things going on here, and we want to make sure we don't lose anything. So what I'm going to do is write down, let's see, x for 2.4, just to kind of keep it straight, is 0.177, let's say 1. Okay. I was debating trying to put a few more decimal places in there, but I think we'll just stick with this for now. Okay, so now I'm going to do the same thing again, but I'm going to find the x value for 1.6. Also, you might know sometimes your textbook refers it to the a value, because remember, in the formal definition, we refer to the value that it's approaching as a. So technically here they would say like a is 0, but I'm just referring to it as x to kind of keep it a little bit straight. All right, so I'm going to go back to y equals. I'm going to go ahead and clear out the 2.4, and I'll go ahead and enter 1.6. You also have the option of like putting both lines in there at the same time and finding the intersection point that way. But I just wanted to try to keep it straight for you guys and keep it kind of one step at a time. Okay, so we're going to do the same thing again. We're going to find the intersection point between our equation and 1.6. And this time they tell us that the x value here is negative 0.2321. Okay, so I'm going to go ahead and write that one down. Okay. Okay, so from here, what we need to do is we need to figure out the deltas. So we know from our 1 delta, I'm going to go ahead and make this bigger again. We know from our, hopefully, kind of information about the different deltas, what they mean. So we're going to find pretty much the distance between 0.1771 and 0, and we're going to find the distance between negative 0.2321 and 0. Now it kind of works out good that it's to 0, because you don't really have to do too much math to figure out what the distance between these would be, right? Because the distance from 0 to 0.1771 is just 0.1771, and the distance from 0 to negative 0.2321 is just 0.2321. Okay, so, and we, as a reminder, always want the smallest one, because the bigger one would give us, if we used the value of negative 0.2321 and positive 0.2321, we would be too far away in our epsilon. Okay, so we don't want this bigger one, we want the smaller one. So for this one, I'll just go ahead and they said 3 decimal places, so I'll say 0.177. That's one step, and then we have to do it again for 0.2. Okay, so just as a reminder, I mentioned this briefly before, but we're going to want to do this for, instead of 2.4 and 1.6, we're going to be doing this for 2.2 and 1.8. Okay, so let's go back to the drawing board. I'm going to go ahead and clear out what I wrote down for these x values, so I just don't get myself confused when I have the new values up. And we're going to do the exact same thing again, but again, I'm going to go to y equals. This time I'll go ahead and put them both in at the same time, just so you can sort of see what that would look like. So again, I'm going to go 2.2 and 1.8. Oh, also, sorry, I think I forgot to mention this before. I did change my window before here to zoom in on the area that we're looking for. So you do have to do a little bit of thinking about a good window. I went ahead and went from -1 to 1 in my X values since I knew that the limit was approaching 0. So I would recommend you pick a window, close in the X values to the A value, what you're approaching. So since the limit's approaching 0, I went ahead and went from -1 to 1. And then for the Y values, since I knew that it was going to be 2, I just kind of went from 0 to 4, since I would figure that would be smack in the middle. Okay, so here are now my 2 Y values. That would give me an epsilon of 0.2. 2.2 and 1.8. So we're going to do the same situation again, where we're going to go ahead and find those X values this way. Again, on the ones that we did on the notes, we did this just by solving it algebraically. So this is similar, but now we're just using the graphing calculator to kind of skip having to do that work. The one thing is, if you put the 2 equations in at the same time, just be careful that you, I'm going to go ahead and erase this part too. That you make sure when it says curve 1, curve 2, it is referring to the ones you're finding. So for instance, this red line, I can tell that's 2.2 because that's higher up. So the intersection point here, I'm going to go ahead and write down is 0.0938. Okay, so that is, I'll go ahead and label that X at 2.2 is 0.0938. And we're going to do the same thing again, but again, we're going to do it for 1.8. So we'll do second trace, intersect, and then we'll go ahead and scroll over a little bit closer to what we're the one we're looking for. And now see how here it says second curve? That is not the curve we want. We want the other one. So you just have to arrow key down to make sure that it's talking about the equation that we're looking for. And so you'll see the X value there is negative 0.1073, we'll go ahead and say. So I'll go ahead and write that down. X of 1.8. And again, same thing. We don't have to do too much actual subtraction since the limit is approaching 0. The distance from 0 to 0.098 would be, oh, sorry, I wrote down the one from last time. Let me jot that, let me fix that. Sorry, negative 0.1073. Okay, so you can see that the distance from 0 to 0.0938 would just be 0.0938, and the distance from 0 to negative 0.103 would be just 0.1073. And again, we want the smallest value. So we'll go with the 0.09, we'll go 4 since they only want 3 decimal places. Okay, so again, that was how we did something like number 5. I understand why that one maybe had some questions because we hadn't really practiced in class together using the graphing calculator to get out those Y values, and you might have been a little stuck on that. Also, just making sure we keep track that the epsilon is talking about the distance from the limit in the Y values, okay? And then delta is talking about the distance from A in the X values. Okay, so that's how we would approach something like number 5. Again, I'm going to have pick one more to solve that. So hopefully when you watch these 2 videos, if you are having trouble, you might be feeling a little bit better. Okay, if you are confused about anything from this video, please just shoot me a message and I can help explain it to you. And I will see you guys Monday. Thanks.